Good afternoon, everybody. Welcome back. My name is Fouad Farid. Welcome again to DataCon LA. I hope that you've had a great day so far. We had to sort out a couple of technical issues, make sure that people online can follow us. So let's see. How was the food? The most important thing first.
It was great.
Sandwiches were great.
Great. And I hope that you had a productive day so far. Very nice presentations in the morning. Hopefully you can follow. We have 3 sessions in a row today related to each other today. So the first talk is next generation of data platforms based on data mesh principles. Himateja is a senior manager at data streaming platforms, helping data engineering teams optimize, scale, and secure their processing based on data mesh principles and tools to run a data pipeline. I don't want to hold this back any longer. Please, only 2 things. Save all the questions at the end, because sometimes the speaker already responds to some of the questions that you have in the next slide. So wait, and at the end, there will be plenty of time for question and answer. Any questions? Let's get started. Please join me in welcoming Himateja.
All right, let's get started. Welcome everyone to my talk on next generation of data platforms based on the data mesh. A quick introduction, my name is Himateja and I work as a senior manager at Disney Streaming. Can I have a quick show of hands of how many data engineers in the room? How many overloaded data infrastructure engineers? Yeah, okay, hopefully this talk will help take some burden off of you. First technical problem, clicker is not working. Okay, here it is working. Thank you. Okay, so who are we? We are the data foundation platform, and we handle the cloud-based big data infrastructure services for Disney Streaming, which is Disney Plus, Hulu, and ESPN Plus. We handle the infrastructure automation for all of our data engineering teams. My team is responsible for establishing the architecture, the security standards, and also rolling out the best practices around all data engineering. We also manage the foundational services and tools for the big data platform. So what exactly we do? We build and maintain a core platform, and we've onboarded about 15 plus data engineering teams onto the platform where they can run their engineering workloads. So what exactly is a core platform, right? A core platform is a full ecosystem that is built to be agile, secure, privacy enforced, and governed. So the domain-driven architecture, which I'm going to talk about in this presentation, it tilts away from being the monolithic centralized platform into a distributed and autonomous environment. The goal of this platform is to produce data which has a high standard of quality, privacy, security, and it enables sharing data both internally and externally in a very easy way and also in a seamless fashion. Before I start the talk, I want to give some credits to where it is due. Domain-driven design has been around for a long time and in the software engineering world, and now it's come to the data engineering world. The inspiration for our architecture is derived from this article published by Zamak on data mesh. I would like to take a step back and talk about the evolution of data platforms. When we initially started, we were running enterprise warehouses, which were running on proprietary softwares and in on-prem systems. Right? There was a tight coupling of storage and compute, and all the processing was highly centralized. Then came along the data lakes in 2010 and the adoption of open source. So data lake suddenly became the silver bullet, and we have teams writing all these bad jobs, transporting data from the source to the destinations. This is exactly the time when the concept of distributed processing became very famous, and a lot of organizations started to create these hyper-specialized pipeline engineers who are like ingesting, transforming, loading the data. Then came along the adoption of the cloud. With that came, the unification of batch and streaming process using Lambda architecture, Kappa architecture, and so on. So what embracing the cloud did to us is we were able to clearly separate the storage from the compute, and they could just live anywhere and run anywhere seamlessly. Even with the advent of this distributed processing, the monolithic data platforms still ruled. Even though we've broken out of this centralized control and we have decomposed the pipeline, it is still vertically fragmented into these ingest, process, and serve. What this does is it creates a siloed and specialized ownership of the teams and the processing, and it really became an impediment for teams to move faster. The monolithic platform poses a couple of pain points which are outlined here. The first thing it does is, it decouples the data producers from the data consumers. The data producers are still running in the data platform, and they are vertically fragmenting. They're trying to fit themselves into these functional phases of ingest, process, and serve, and they're very far away from how the consumers use the data. This leads to an architecture that is orthogonally biased from the business axis of change, meaning that the functional components are vertically fragmented, whereas the business and the product is evolving horizontally. Right? So this paradigm also creates a lot of dependency on the upstream and downstream systems and creates high coupling between all of these phases. Because of this, we have highly specialized teams which are doing specifically ingest or transform or load. And also the backlogs that the product owners create are completely aligned to these functional phases, as opposed to being aligned to the business requirements. So this paradigm has created a friction between how the business users want the data, as opposed to how the data engineering teams are actually producing the data. So that's when we decided that now is the time to revamp the architecture. The domain-oriented platform, which I'm going to detail out in the session, is it aims to solve all of these pain points. So what it does is it aligns the architecture horizontally along how the product evolves and the business needs. So as you can see in the diagram, the product owners are still running your ingest, process, serve. However, what happens is they are tightly coupled to a domain, right? All their expertise is shipped to that domain. And what that does is it allows each of these domains to evolve independently of the other. So no longer these product owners are, having backlogs that are in that the decomposed pipeline. So it also helps to create domain-focused engineering teams. So all the domain expertise comes together, and there is a higher collaboration, and the data producers and consumers are talking the same language when they're doing this. So this leads to the teams producing a high quality of data and data products with a lot of attributes that I'm going to talk about in just a little. Okay. So we talked a lot about domains and each expertise being in its own domain, right? How exactly do you do this? How do you create this cohesive platform where all the domains come together and they are no longer fragmented or siloed? Right? So that is where the core platform comes, and it ties all these domains together. So what are the responsibilities of the core platform to have this architecture successfully work in its implementation? So the core platform team is mandated that they have to reduce the time from when the engineers start producing the data to the time when it's actually shipped, right? So so what that means is, imagine that if you ask a data engineering team that okay, just bootstrap this domain and start everything from scratch and start running. Right? So that is going to take a lot of time, and also there's a lot of standards that will be missed in the place, and probably the data engineering teams will not think about all the cross-cutting concerns. So that is where the platform team comes and says that, okay, we are going to bootstrap the domain for you. We're going to give you all the foundational blocks that will help you write your pipelines, that will help you stand up your infrastructure, and you are free to take it and build on top of it. Okay, so because of that paradigm, what happens is the core platform is responsible for baking in all the data constraints around the security, governance, logging, metrics, all of that. So this allows the data engineering teams to purely focus on what is the business ask here, and what is the data that I have to produce that suits the business needs. I'm going to talk about a couple of core platform capabilities that help make this happen. Right? The first thing is self-serve capabilities. Right? So now that we have put all of these data engineering teams in their domains, it just feels so siloed, and it just feels like probably the core platform will become the bottleneck. Right? To avoid that, what we did is we enforced self-serve capabilities both on how you write your pipelines. So we shipped out loosely coupled components that help you write your pipelines better. We shipped out infrastructure blueprints that will help you stand up your infrastructure resources, and also we shipped out some frameworks that will help your business users access the data that is produced. So self-serve is at the core of what we build on the core platform. Next, the core platform is responsible for the scalable governed cloud object stores, which means that all your object stores have to be encrypted and follow the best practices. Right? Oftentimes, what happens is the data engineers produce all these data assets or data products, but they are hardly discoverable by the business users. So there's a huge disconnect. So the core platform mandates that whenever you produce data products, you have to publish the metadata and make sure that the data is discoverable. With the advent of CCPA and GDPR, we are sitting at the center of all of it and making sure that all our data is in compliance with all these privacy rules. The core data platform is also responsible for the access control and the federated identity management. What that means is that we define a standardized way via personas of how people can access this data, and we only give the right set of access to the right people. And we've like I said, we want all the signals. Although we want the data engineering teams to operate autonomously, we still want our eyes everywhere on all of these domains. So what we do is we bake in monitoring, alerting, logging into all of these domains that are sending us signals, so that we are proactive in fixing any issues that can happen on these domains. So this also means that any domain or any team that's going out of compliance, we are able to detect and say that this is not according to the larger organization's best practices. And finally, we also give data pipeline orchestration to these teams. So as you can see here on the right, the core data platform is providing the common standards, conventions for your governance, security, and all the best practices. And it's forming the foundational block. Okay, so this is where it all visually comes together. You can see that each of these domains are sitting here and producing data products, right? Each domain is running its own ingest, process, and serve. So visually, this is quite literally, you can say So each of it is running in its own cloud account, right? And doing its own thing. But what is running inside that cloud account is fed by the foundational blocks that the core platform says, which is the framework for how you have to write pipelines, or the framework for how you have to stand up infrastructure. Right? So and all of these domains can talk to each other and get the necessary information. So I'm going to detail some of the requirements that the platform needs to address so that this is usable. Right? So first of all, it has to be fully automated deploy. What that means is there is no way you can have like an army of engineers clicking on the UI and having all of these provisioned. Right? So we rely heavily on automation on the CI/CD front, automation on how you use your frameworks and all of this. Then upgradability. Like I said, each of these domains is allowed to evolve on its own without any connection to the others. So that means that any patches or any optimizations that each of these domains would like to do, the core platform has to provision that. We bake in logging, metrics, alerting, and traceability into all of these domains, and we build dashboards on top of it in our observability accounts, so that everybody has a view into what is happening in each domain and how are the resources being used. We work heavily with security and governance teams to roll out the compliance policies for everything that we do on the domains. So whenever all these teams are operating autonomously and deploying things, we want them to register to the core platform. By doing so, we are able to monitor and figure out whether they are compliant with the larger organization or not. So for metadata, like I said, whenever data engineering teams publish data products, we ensure that they also publish this metadata, and we also ensure that this metadata is unified and showed across a data portal, so that our business users sitting on the other end are able to log into the data portal and discover data assets. All of this said, what we don't intend to do is we don't intend to do one-off deployments, right? The data engineering teams are, they have the autonomy to do whatever they want on their platform, and they're able to promote whatever they have done onto the core platform if they think that it will serve the rest of the domains. But we don't do one-off deployments. And finally, the core platform has to have a mechanism to raise PRs and bug reports, so that it encourages a culture of distributed and open source development. Okay. I'm going to take a step back and talk about the 4 principles of the data mesh on which the whole platform was built. So there are 4 fundamental principles: the principle of domain ownership, the principle of data as a product, self-serve data platform, and federated computational governance. I'm going to deep dive into 2 of these, which is data as a product and federated computational governance. But before that, a quick look into what is the principle of domain ownership. So a principle of domain ownership comes naturally if you have worked with it in the software engineering field and you understand what a domain is. It just simply means that you bring all the domain experts together and set up this highly collaborative environment where the data producers talking to the data consumers, and they're working in tandem to produce high quality assets that the business users need. We talked about the self-serve data platform, where I said the only way the scale we can achieve the scale that we want is through automation, meaning that everything that the data engineers want to do, the data infrastructure engineers want to do, or the business users want to do has to be through a self-serve capability, instead of we becoming the bottleneck. Okay, now let's talk about the data as a product. What does it mean for data to be a product, right? Data is not just a bunch of rows, or it's not just something that you throw out there. It has to have certain characteristics for your end users or your business users to be able to conveniently use it, right? To derive insights. You want to do something meaningful with the data and derive insights. So when data engineers produce this data products, they have to make sure that data is discoverable, meaning there's a portal and you log in, and you exactly don't know what the data is, but you should be able to search and find the data assets that you want to work with, right? Then it has to be trustworthy and truthful. That means it has to have it has to pass the data quality standards and also meet the SLAs, so that data is available when it is needed. It has to be interoperable, meaning that all these different data engineering frameworks that we have should be able to interoperably use your data assets. It has to be understandable. So whatever, you have to do a lot of aggregations and make the data understandable. And it has to be secure, so for any attacks. I'm going to go to the next slide and zoom in and talk more on what is a data as a product. Right? So this is a complete zoom in picture of what happens inside each domain. Right? How do you ensure that your data products are of high quality, and how do you ensure that you are autonomous yet you're complying with what the core platform has laid out? So in software, a quantum is like the smallest component that you could deploy by itself. So similarly, in the data engineering field, a data quantum is that smallest component that you could ship and run. It can run by itself in the domain, yet it encompasses everything that the data as a product needs. So as you can see, the data onboarding is our plain old pipeline, the ingest process serve, which is sitting there and doing like these, transporting data from source to destination in a format that is needed, right? So if you see here, data pipeline is just one part of the whole puzzle, right? So this is a complete paradigm shift where data pipeline was the first-class citizen. We're moving from there to the data product being the first-class citizen. The next is the dictionary. So this is where we enforce that the data engineering teams publish metadata, and then we unify it and we publish it in a dictionary so that it's accessible. The next is the observability plane. So because of the self-serve components and the loosely coupled frameworks that we ship to all of these domains, on top of which they are building their pipelines, we have baked in all these observability components into the pipeline. So without any extra effort or any oversight from the data engineering, we just get all the signals that we need to monitor our data assets and our resources. That's the observability plane. The control plane is where you provide REST API access to users outside to be able to access the data. And finally, our first-class citizen, the data product, which is our interoperable data that is published by each domain. So you can see like the data sources are coming in, and a lot of different clients based on their needs are talking to this domain and just getting the information. So that could be your observability clients, your discovery clients, your business users, or your control clients. So that's about data as a product, which is our first-class citizen. Now I'm going to talk about federated computational governance, right? I'm sure a lot of you have heard of data governance and how we have to have policies in place and how data is accessed and all. I think we also need to have federated computational governance on how its data is stored, managed, all of that stuff. So how do you make it possible when you have all this domains spread out and you have this core platform managing the domains? Right? So on the far left, you can see we are operating in each individual account, and each individual account is hosting its own data. You can see that every account is talking to the other account, which is making it very hard for us to govern and adapt to change. So from there, the first step was to jump over and do this, where we completely separate the compute and the data accounts, which is still better, good, some level of separation. But still, if you see, each compute account is responsible for figuring out which data account to talk to, and the roles are living somewhere in the compute account, and it's still harder to govern this. So on the far right, you can see how we provide federated access to data accounts. So what happens is the compute accounts and the data accounts are completely unaware of each other. Anybody who wants to have access to the data account will talk to Federation, which is sitting in the middle. I'm going to talk a little bit about what Federation is in the next slide, but the core idea is it's like the complete separation of data and compute, and each one not knowing where the data lives, but yet seamlessly access the data and do what they want to do. Okay. So this is a little bit more deep dive into how exactly a federation works. The concept of federation is completely based on a separation of the compute accounts and the data accounts. So if you see in this picture, we have all the domains on the top, and one domain has one or more compute accounts based on the environment in which you want to operate, right? And at the bottom, we have the data accounts. So in the compute accounts, there is no data, there's no roles, just all the processing is happening. And at the bottom, you see the data accounts, which is purely all of your data categorized in these accounts. So how exactly do you categorize the data? We fell back onto the characteristics of the data itself to categorize. So for example, you could have financial data, you could have general data, you could have PII data, non-PII data. So you segregate all such data from those with those characteristics and put them in those data accounts. So that enables us to provide access to the data based on persona. So let's say you are a data scientist. You don't really need to have access to PII data to run your model, right? So because your non-PII data is segregated in one account, anybody who has a persona of data scientist is granted uniform access to all the non-PII data. So we are moving away from having these individual access to people, and we move to a persona-based access. And that was possible only because of this clear separation. Now, the accounts sitting in the middle, these are the special accounts. So the federation account is a special account where there is no compute happening, there is no data, it's just simply holding the roles. Remember how I talked about the compute accounts talking to the federation and they talking to the data accounts. So because of that, the compute account will assume a role that is in the federation account, and then the federation account will hold, the role will hold the necessary permissions to the bucket. So example that Forgate instance in the domain 2 can talk to a very specific bucket in account 1, and the control is managed here. So this allows us to give very granular control. Like even though we are so distributed, so separate, you're still able to give granular control to the data. Furthermore, you can see that this architecture, the beauty of this architecture is it's highly scalable. You can keep on adding domains to this, and those domains will come out of the box to you because the core platform team is sitting there and it's bootstrapping all these domains with everything that you need to get started. And you can horizontally scale your data accounts. You can also scale your federation accounts. Like when you're operating at a scale of onboarding 15 data engineering teams, there are like many roles you need to provision. So we have hit the limits on our federation account, the number of roles we could. But the beauty is we could horizontally scale this. And also the beauty of this whole architecture is my team operates data that's from data processing that's from 3 different business units, which is Disney Plus, Hulu, and ESPN Plus. But still, we are all able to co-locate and coexist in this architecture and still run. How we do that is the federation, we have separated out the access at the federation account level. So we have one federation for Disney Plus, one federation for Hulu, and so on and so forth. So this is how we were able to manage onboarding more than 15 data engineering teams and running successfully and dealing with all these downtime, infrastructure downtimes and all. And we were able to standardize how pipelines are written across all of these different teams and how everybody runs in a similar fashion. So last but not least, what are the learnings? I think the first disclaimer I have to tell you is this paradigm is not applicable to everybody. If you are a smaller organization running 1 or 2 data engineering teams, this is just an overkill. But once you go above 5, 10 data engineering teams and you want to standardize how people do things and you want to reduce duplication across these different data engineering teams, this paradigm fits well. So we relied heavily on automation, and the maturity in automation was the key to how we did this. we made sure that data products are our first-class citizens, and we ensure that there's metadata and data products pass the data quality standards. What we realized surprisingly is this paradigm brought together all the domain experts, and suddenly there was a high collaboration between people who are actually producing the data and people who actually need the data. And like I told in the previous slide, the domain approach was scalable. It made the platform very adoptable. So just going back to the previous slide, what that means is you could have an external data account or an external compute account, but still it could plug into this federation and talk to your data. Right? So even though we are completely separate, we are very adaptable. And no, I don't think any architecture comes without its downsides. Yes, we did have downsides, and that's the last point. The biggest problem we had was because of this separation, there was a lot of cross-account access that was needed. One domain had to talk to each other, or for example, Airflow running in one domain had to talk to Airflow running in a different domain to make things work. And what we realized, and we were surprised, is that a lot of AWS services are not rolled out to support this cross-account access. So we had to do a lot of out-of-box. For example, MSK was not able to talk cross-account. So we had to write wrappers on top of the MSK to enable cross-account access. So that was a big learning we had. And with that, end of the session, I can take questions.
Questions? Thank you so much for a wonderful session. My question would be, you mentioned at the end regarding the collaboration of people who were producing the data and the people who were working with it. Can you give us a few examples on this collaboration and how it worked out?
Yeah, so basically, end users are like your business users or data scientists, right? So for the business users, they needed data in a particular format. And before we launched this, what used to happen is they are only in connect with the serve team, right? And it has a dependency on the processing team, and then so on and so forth. So while data is transitioning from there, it was lost. Data was lost in the transit. So then what we did was we really brought together this business user and this dedicated team. Now that it's completely responsible for ingest, process, serve, the dependency was reduced. So the end user could directly talk to one team, like tell them the full picture of, this is what I want.
One person develop the other as well. It's a collaborative process.
Yeah, it's a very collaborative process. Yeah.
Is it on?
I had a quick question. The domains that you mentioned, were the three domains that in your case? Was it the Hulu, the Disney Plus, and ESPN?
Or
No, so that was at just the federation level. Defining a domain at Hulu level will again make it very a monolith. So when I couldn't put it on the slide. Can you hear now? Okay. So what I was saying is, if you define a domain at the Hulu level, it's still very a monolith, right? I couldn't put the details on the slide because they are very proprietary, but I'll give you an example. Marketing is a domain, revenue is a domain, right? So which means the people who need marketing data, they are all operating in that particular domain. And that domain's needs can evolve differently compared to revenue, which is handling financial data. So domains are much more granular than, at a Hulu level.
Follow-up question. How does the cost model work? Do they all pay for their own stuff, or do they do their chargeback model?
So cost is something we didn't include here. So as part of how I said we bake in monitoring logging, we also bake in these cost optimization techniques, and also we ensure that we are receiving cost data from all of these domains. So we are able to show dashboards of which domain is consuming how much and where we could have chances of optimizing. If
Any other
you ask
question?
each of these individual teams to do that, there's going to be a lot of oversight.
Have you been able to, or do you plan to implement this across different cloud providers? Does the Federation accounts make that easier?
Yeah, we don't have plan-based. That's the beauty of Federation. It allows you to be in multiple cloud providers, and because of the complete separation, you can still seamlessly access.
Yes, you mentioned the data account has been defined first, but a federation account, it will be dynamic change, or you define some role is fixed for the federation account.
So you're asking federation account is?
Yes.
What about the federation?
Is you defined or also dynamic change?
Sorry, I'm not following.
I mean, based on the model, you have 3 tier, right? Data account, second layer is federation, then computer presentation layer. So federation account, how you define it based on some role or based on some access or based on your define?
Oh, okay, I got it.
Yeah, second question, you mentioned domain, the dynamic change, but some data definitely cross each domain, like HR data, market data, they definitely some crossing or share some data. How you decouple them, make sure they not have a duplicated data, maybe some data don't conflict each other. Thank you.
Yeah, so for the federation, right, it's not a one-on-one relation between federation and data. The federation account can handle multiple data accounts. So if you're talking about like a federation for Hulu, provided legal approves, right, we are able to let it talk to data accounts that are related to Disney Plus, right? So everything that is in federation is governed, by the team, and all the access, everything is governed. It goes through a strict approval process so that only the necessary roles have the right set of access.
Thank you so much for the talk. We love your shoes. But also just wanted to, you're dealing with a lot. You're dealing with a lot. Okay, we've got all these organizations that have kind of been pushed together. My big question is, how do you get teams off of their legacy systems to unify them under one model that works?
Been there, done that. So when we built the platform and we had to migrate, I had to literally set up collaboration with all of these 15 teams, like work with all the directors and senior managers of those teams. What really helped, which we learned during the process, was you cannot operate in vacuum, right? This is a collaboration, and they kind of feel that this is not their responsibility, right? And they have their own deadlines, priorities, whatnot. So I had to set up a special team, organize my team to set up a solution architect team. What this team does is they have the knowledge of the core platform, and it's like how solution architects work with Databricks or other platforms, right? So they have to understand the requirements of the data engineering team, and they have to prevent a lift and shift. We don't want to do what we did in the legacy. We want to do it in a fashion that conforms to the core platform standards. So that's where that solution architect team, it was a huge team, 5 team members. They would just be the first point of contact to all of these data engineering teams, and we would outline, what are the responsibilities of their team versus what is our responsibility, right? And we're a handshake and work in that fashion. But it was not an easy feat. But now that we're running in this core platform, we feel more comfortable. Because prior to that, we had 3 different monolithic platforms, everybody doing their own thing and no standardization, nothing.
Okay.
Oh, okay. So thank you, speaker. I think some of us also heard of another word, data fabric. So in your opinion, what would be the main difference between a data mesh and data fabric?
Yeah, I have not dealt that much with data fabric. Just been focused on the data engineering. So.
Any other questions? Yes. Oh, yeah, there's one.
Thanks, great talk. So as someone who works with primarily much smaller teams than the one that you're working with at Disney, what do you feel is kind of the subset of this, like the kind of some of the core ideas from this that can be extracted for a team that maybe doesn't even have one complete data engineering team, but perhaps sits within an organization of, several product engineers?
Mm-hmm. Yeah, you could borrow a few of these. Like if you're really small and just getting started, then I think if this is just an overkill. But then like, from two or more data engineering teams, you could just slowly borrow, like separate complete your compute from the storage, have a federation. Because when you are small, it doesn't seem like a lot, but people just keep building on top of it and it becomes a habit. And then it becomes like this big pain. So you could definitely borrow the federation principles.
Well, thank you very much, Himateja. Okay, one last question because we are almost out of time.
I'm guessing you all enjoyed the talk. That's why there's so many questions.
Are you going to be there? Good.
I was going to ask if during the requirements gathering with the product team, do you ever work within a logical data model or conceptual data model where they actually map together like the objects of the system and on names, labeling?
Yes. So the data model itself, we let the engineering teams decide that because we want to give the autonomy. We don't want to have the control. We're like, please take control, but make sure you're adhering to the standards. But then we were big on all these naming standards and how right to the point that if you create a bucket, you have to create these tags. So we know what this is. Right? So at every level, we had create tagging and we enforced a lot of rules, but the model itself, we left it to the data engineering.
No input from product.
Each of the domains, they will have the product owner and they will sit together and define. But as a core platform team, we don't have any inputs into their data model.
Well, thank you very much for a great presentation. We are absolutely out of time. But let's thank my co-host, Ari, and all the yellow shirts that you see, all the volunteers, Subash down all the way, that are running a great event today. I hope you're enjoying it. We have another session at 2 and 3, very related to it. Himateja is going to be available right after the start for a while. She's gracious to stay. If you have, very specific questions, you can talk to her about your specific case. Thank you very much again. Great job.